Hey there, welcome to this amazing video in our series. So if you're watching my video for the first time, then I would like to mention that this particular video is a part of a series of which link you will find in the description. So be sure to check out the description if you want to go through the entire playlist. So we'll talk about what we are going to cover in this particular session. So this particular session is going to be about service registries and inter-service communication. So we will begin talking about what are service registries and the importance that they have in the microservices world. We will then do a practical setup of service registry, and then we will eventually register all our microservices with the Eureka Server. We will be even talking about load balancing and how you can make use of it. So if you're not aware of any of these concepts, or if any of these concepts doesn't make any sense to you, don't worry, we will cover everything right from scratch. So even if you are a beginner, you will have a clear picture of what every concept means and how you can implement them practically. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hey there, welcome to this class. So let us start talking about this concept of service registry and why do we need it in our microservices architecture. So first, let's start talking about what is a service registry. So a service registry is used in a microservices architecture to enable dynamic service discovery. Now, in microservices, inter-service communication is really important. And for inter-service communication, we have hard-coded URLs that we can use. So you can hard-code the URLs and you can use those URLs to communicate with other services. But this is not a good practice. Now, this can be cumbersome, error-prone, and this is not a good way of talking to another service. So this is another approach, which is with the help of service registry. So what happens in case of service registry is you have a service registry which looks something like this, and you have other microservices like this over here. So you have company, job, and review service, for example, and you have a separate service registry. So what will happen is every microservice will register itself with the service registry, and service registry will help with service discovery. So service registry essentially is like a phone book for microservices, or you can call it like a database, or you can think of it like a database that has been populated with the locations of different microservices that exist. So service registry will know all the microservices that exist in a particular architecture. And if you want to talk to any microservice, you need to go to the service registry and get the location of that particular microservice and communicate to it. So this is how the service registry concept works. And like I said, you can think of it like a database populated with network locations of service instances. Now, all the microservices will register themselves with the service registry. So by all, I mean all, or whoever wants to get discovered within the network. So they will register themselves with the service registry, and service registry will help with the service discovery. And when the microservice shuts down, they can deregister themselves. Okay. So they automatically deregister themselves whenever they shut down. Now let us talk about this entire process as to how the service discovery process works. So let's say you have a job microservice and you have a review microservice. Okay. So job microservice will register itself with the service registry that exists in the microservices architecture. Now, whenever the review service wishes to communicate with the job service, review service will instead go to service registry and do a service discovery request. So a service discovery request is like a request to communicate to a particular service. And then service registry will help the review service to communicate with the job microservice. And this way the communication happens. So the benefit over here is instead of relying on the individual microservices to discover themselves on their own, so instead of using hardcode URLs in that place, what we can do is we can have service registry, which is a centralized server to which every microservice can register. And whenever you have to communicate to any microservice, you do a service discovery request and then you communicate. So this helps, and this is a better approach as compared to those of hard-coded URLs. Like you can't have hard-coded URLs everywhere. Okay. So this is about the concept of service discovery and service registry. Now let us talk about how it will work for us. So if we have multiple microservices, we will be registering all the microservices with the service registry over here. Okay. And everybody will register. So whoever wishes to get discovered in the network. And then whenever there is a request that is supposed to be done to another microservice, service registry will help with that. Let us talk about why using a service registry is beneficial. So there are several reasons as to why this concept is really beneficial. So the number one benefit is dynamic service discovery. So with a service registry, microservices can dynamically discover the locations of other services at runtime. Okay. And this essentially eliminates the need for hard coding URLs. So imagine if you don't have this concept, how would you communicate? So if you have one service that is being hosted on a server and then you have another service that wishes to communicate. So what you will do is you will take the URL of the second service. Okay. So the service that you wish to communicate with, you will get the URL of that and you will hard code it into the service that wishes to communicate. So that's one way of doing it. But with service discovery, this need of hard coding URLs is completely eliminated. And this hard coded URLs thing can be problematic, okay, in dynamic environments where services can be added on the fly and removed on the fly or even relocated. So if, let's say you are hard coding the URLs, let's say, and the service location has changed. So the URL will also change, IP will change, of course. So in that case, this becomes an issue. And that is why there is a need for something that manages this dynamically. Okay. Because in microservices architecture, everything is loosely coupled, like multiple services are loosely coupled. And there is a possibility. So if you are using IP address to communicate, let's say, okay, you are using the server IP. So there will be a requirement or a mandate that that server IP cannot change. And what if it changes? So there will be errors all over. Okay, so if we move the server, the IP changes. And if you like do anything like service, you added a new service, you removed some service, or you do anything with the microservice. So the possibilities of failure with hard-coded URL are higher, and it's not a good practice to go about that. Okay, so that route is not good, and that is why this particular concept exists. So this is about dynamic service discovery is what it helps with. Then we have load balancing. Okay, so a service registry can also provide load balancing capabilities, and it does so by distributing the incoming requests across multiple instances of a service. So if you are having a microservice, and let's say if there is a lot of load on that microservice, you can add multiple instances of that microservice to scale the needs of the traffic. Okay. And in that case, you might need some load balancing features, and that is even what service discovery can help you with. So service discovery is beneficial in that way with load balancing as well. Then you have fault tolerance and resilience. Now, what does this mean? So, in case of microservices architecture, where everything is loosely coupled and there are different services, there can be a possibility or a scenario where a service instance fails or becomes unavailable for a certain period of time. And this way, how can service registry help in this? Okay. So let us say if a service fails and other services in the network are not aware of this failure, then what will happen? Like there will be errors all over. So other services will also try to communicate to that service without knowing that it is down. Okay. And in this particular scenario, service registry comes to the rescue. So if a particular service instance fails or becomes unavailable, service registry can detect the failure and update the registry accordingly. So like I said, it's like a phone book. So it updates that, hey, this particular service is down for a while. Okay. And this allows the other microservices in the network to know that, okay, this is something that we need to be aware of, and we need to redirect the request to healthy instances accordingly. Okay. And this can improve the fault tolerance and resilience of the network. So resilience is basically not failing. Okay. And fault tolerance is essentially the ability of a network essentially to survive the faults. Okay. So in this way, since service registry is aware of service instance not being available, it can update and it can be aware as to how to route the requests. Then we have scalability and elasticity. So as number of microservices and instances grow, managing and coordinating the interactions becomes much more challenging. Okay. So if you don't have a service registry, it will be a chaos. Okay. So you won't know who is communicating with whom. So in that case, if you have a centralized service registry, then service registry provides a centralized mechanism to manage service endpoints, and it makes it easier to scale the system up or down based on a particular demand. All right. So this is about scalability and elasticity. Then you have service monitoring and health checks. So service registries include features that enable you to monitor the health of the registered microservices. And they periodically check the availability and responsiveness of the services. And they have a mechanism using which they mark them as unhealthy or healthy based on some criteria that they have. Okay. And this information is used then by the rest of the network for better visibility, decision making, and managing the system. So service registry indeed is really beneficial, and it's a great thing to have in a microservices. Okay. But now the thing is, how are we going to implement service registry? Okay. So there are several service registry solutions out there, but the most popular one that will be using with Spring Boot is Spring Cloud Eureka. So if you head over to Google here, so I'll just switch over to my browser, and here I'm going to say Spring Cloud Eureka. Okay, so you'll see this first link over here, which is Spring Cloud Netflix. Okay, so Spring Cloud Eureka essentially is a client, and that is a part of Spring Cloud Netflix project. And this Netflix is like the Netflix.com. Okay. So yes, this was built and developed by Netflix, and it was for its own internal use, and then it was made available for everyone else. Okay. So Netflix Eureka was developed by Netflix, and it's a service registry and discovery server that allows applications to locate and communicate each other in a distributed system. Okay, so you can think of it like a centralized repository for service registration and discovery, and it makes it easier for microservices to find and connect with each other. So you can read more about Spring Cloud Netflix, and you can see it has some service discovery features that have been mentioned over here. Okay, so we will be making use of the dependency for including Eureka Server into our project. Okay, and you can see it's mentioned a few times over here. All right. So yeah, how it will work is whenever we include the dependency, we will get a separate Eureka server, which will act as a service registry for our network or for our microservices project. So yeah, that's about Spring Cloud Eureka. And that's about service registry and the importance of service registry in microservices architecture. Welcome back. So let us start implementing and setting up the service registry with the help of Eureka Server. So we are going to make use of Spring Cloud Eureka, which is a part of Spring Cloud Netflix project. So what I'm going to do is I'm going to head over to start.spring.io. So to add Eureka Server into our microservices architecture, we will need to add it as a separate server. And adding as a separate server will require us to create a new Spring Boot application. And that is why we have landed on this website, start.spring.io. So this is our favorite website from where we create new Spring Boot projects. So select Maven, select the latest version of Spring Boot. Make sure you're not selecting snapshot version. Then add the group ID. So I'll add the group ID as com.embarkx. All right. And artifact ID, I'll keep as service reg. So I'll say service reg. So this is service registry. Okay. And I'll have service registry for our microservices. So description is service registry for our microservices, and you will see package name auto generated. We have packaging as jar, and Java 17 is what we are using. Okay, so this is something that we have added. Now what we need to do is we need to add some dependencies. So I'll say add, and here I need to say web. So this is one dependency that we will have to add. We'll have to tell Spring that this is a web application. One more dependency is we will say Eureka. So you will see two dependencies come up. So Eureka Discovery Client and Eureka Server. So since we are setting up this server, we need Spring Cloud Netflix Eureka Server. So I'll select this. You can explore the pom.xml if you wish to. So here you can see there are two dependencies that have been added, the web and the Netflix Eureka Server. Okay, so I'll say close and I'll download this as zip file. So after you have downloaded this as a zip file, you can extract it. Okay, so I'll say extract here. Once the file has been extracted, you will see this folder appear. Now what we need to do is we need to add this as a project. Okay, so I'll head over to IntelliJ IDEA. Now in IntelliJ, I'm going to add a project to this layout here. So I'm going to head over to Maven here on the right hand side. I'll click on this plus icon. So we'll add a new Maven project. I'll scroll down and here we have this project service reg. So service registry, I'll say okay. And you will see the service registry project appear on the right hand side. So it's been added to our unified view now. Okay, so I'll just collapse this a bit. Now, once this is added, I'm going to close all the tabs and I'm going to expand the service registry. Okay, so we are getting an error here. Okay, so the error I got was related to syncing issue, and if I clicked on sync again and the issue was resolved. Okay, so there was some problem with the network to get the dependencies, which is fine. So we'll head over now to main Java and I'll open this service registry application. Now in this particular file, we need to add an annotation. So we need to tell Spring Boot that this is a Eureka server. Now, how do we tell this? With the help of a simple annotation, which is enable. So I'll say enable Eureka server and I'll say enter. Now you can take a look at this dependency here or this import statement here. So Spring Framework, Cloud, Netflix, Eureka Server, enable Eureka Server. So this is coming in from the dependency that we have added. So if you go to pom.xml here, we added the dependency which is for Eureka Server. So this is a dependency that we have added, okay? Spring Cloud Starter, Netflix, Eureka Server. So because of this dependency, we have access to this particular annotation here, okay? And this is the annotation responsible for enabling or converting this particular application into a Eureka server. Now, by specifying this annotation, we have all the features enabled for having a service registry over here, okay? So now what we can do is we can head over to resources, application.properties. Now here we need to specify some properties here. Okay, so I'll first say spring.application.name. So we need to first give this particular application a name. So I'll call this as service registry, like so. Then I need to say server.port. So we'll have a different port for this particular application. So I'll say 8761. So this particular application will run on this particular port, okay? I'll say eureka.client.register and I'll say hyphen with Eureka. So this is one property that we need to specify and one more property, eureka.client.fetch registry. So these two properties we have to set, okay? So this property says whether you need this application to register to Eureka, okay? So this particular service or this particular application itself is a service registry, which is nothing but Eureka server, okay? So I need to say false because a Eureka server cannot register with itself. So we need to set this as false, okay? Now fetch registry. So what does this mean? So does it need to fetch the information of the registry? It's a registry itself. No. So I'll say false. So we need to set these two properties to false and we need to add these two properties which specify the service registry, which is the name and the port here. Okay. So with this, we are done configuring our service registry Spring Boot application, which is nothing but Eureka server. And we have done this with the help of the Netflix dependency. So we have added this dependency from Netflix Cloud Starter project, which is of Eureka server. Okay. And we are making use of Eureka server here to get the service registry up and running into our application. So we are done with the configuration. All right. So if you have done this successfully so far, it's great. And we will run this application shortly. Welcome back. So we have the service registry project set up and created. Now let us run this project. So I'll go to service registry application and I'll say run. So our service registry application is running as a service now, as you can see here, and it is running successfully. Okay. So here in the port, we have specified the port number as 8761. So let us head over to this port and let us see what we see over here. So if you come over here, you see this page that has been made available to you. And this page says Spring Eureka here. You have the status of environment here. Okay. Some information. And here it says application, no instances available. So this is under instances currently registered with Eureka. So what this means is we have Eureka server up and running successfully, but there are no instances that are currently registered with Eureka as of now. And that is totally expected because we have not configured anything to work with Eureka yet. But this is how you can run the project and access this page here which gives you a gist of what all services are available with our Eureka server. So let us start registering the first service. So the first service that we'll register is the job microservice. And to register job microservice, we will have to do some configuration changes in the job microservice. And for that, we need to add some dependencies as well. So I'll head over to Spring Initializer here, and I'll remove these dependencies. And if you click on Add Dependency, and if you say Eureka, so you will see two files, like two dependencies over here. So you have Eureka Discovery Client and Eureka Server. Eureka Server is to set up the Eureka Server, but this time we'll make use of Eureka Discovery Client, which is for registering purpose. So I'll go to Explore now, and here, if you scroll down, you will see this particular dependency appear over here. So I'll just copy the dependency. I don't need to get or download the entire project because we have the project already set up. And I'll head over to my IDE. Now here, I'll minimize this and I'll go to job microservice. Here, pom.xml. And here under H2 database or anywhere within the dependencies tag, I'm going to paste the dependency that I have copied. So you will see after pasting, everything turns out red immediately. And that is because we need to get the dependency. So this dependency is not found. And how do we get the dependency? So you will see this icon appear over here on the right hand side whenever you do any changes to the pom.xml file. And if you click on this, you can see resolving the dependencies. Okay, so we got an error, could not find this dependency here. So the reason this has failed and we got this dependency error is because we are missing one more thing. So if you head over to start.spring.io here, if I zoom in, let me zoom in a bit. And here, if you scroll down, so here we have the dependency like Eureka client. And if you scroll down, you also have the dependency for Spring Cloud. So this is something that you need to add. Okay. So I'll copy this. So under dependency management, this needs to come in. Okay. So we'll head over to our pom.xml. And if we scroll down here, okay. So we don't have dependency management. So we need to add this after dependencies and before build. So after dependencies and before build over here, like so. So let me resync now. Okay. So we even need to add the cloud version. So here we are making use of this variable, or we are saying we need to specify the cloud version here. And if you scroll up, here is the tag that specifies the cloud version. So I'll get this tag and I'll scroll up here and we'll add the tag here. Okay. So this specifies the Spring Cloud version. The Java version is also specified and we are using the Spring Cloud version over here. Like so. So to resync, I'll click on this Maven and I'll click on reload all Maven projects. Okay. So you should see the error go away and everything should sync perfectly fine. Okay. So remember whenever you are adding this, like this Eureka client to your project, you need to add Spring Cloud as well, like this tag over here. And you need to add this tag as well. Okay, this specifies the Spring Cloud version that your project will use. And this is because Spring Cloud Starter Netflix Eureka client is part of Spring Cloud project. Okay, of course, Spring Cloud Netflix project, but you need Spring Cloud as well. All right. So this was not needed when we did this for service registry. And the reason is because we downloaded the entire project. So everything was set up. Okay, but this is needed. And once you have done this, you have all the dependencies that you need to register job microservice as the client. Okay. Now what we are going to do, so we need to add some properties now over here. Okay. So these are the properties that we had added for our Eureka server, but we need to go to job microservice, SRC, main, resources, and application.properties here. Okay, so here we will add, I'll say Eureka. Okay, and these are all the properties that we'll need for Eureka Server. Okay, so to register this as a client, what properties do we need? So a couple of properties that we'll need is these. Okay, so I'll just paste this over here. So here we are saying Eureka client register with Eureka. Instead of false, we will have true, because job microservice needs to register with Eureka. So this is true. Does it need to fetch the registry? Yes, it needs to. So I'll say true for both. Now, how does job microservice know where Eureka Server is? So where is Eureka Server running? Eureka Server is running on this particular port on localhost. So we need to give this address. So if you go to our browser here, we have Eureka Server up and running over here. Okay. So what I'm going to do is I'm going to come to this application.properties and I'm going to say Eureka client.service URL dot, I'll say default zone, like so. And here I'll paste the URL and I'll add Eureka in the end. Okay. So this is the URL which will be used by our microservice to register as a client. And we have specified two properties here. We are telling the job microservice to register as client with Eureka and also to fetch the registry. Okay. Now let us reboot our job microservice. Okay. So what I will do is I'll go to the services tab and I'll click on job microservice and rerun. So this will start running our job microservice and let us wait for it to completely boot up. So it's running now successfully. Now, so you can see over here some logs appear. Okay, you can see discovery client. Okay, and here if you scroll down, okay, you can see over here registering the service. So the service is registered. Let us see here. So here if I refresh, okay, so the application is unknown. Okay, and why are we getting unknown? In logs also we saw unknown a bit, and there is a reason for this. The reason is we don't have a name for our job application, okay, which is not good. So we need to add a name over here. So to add a name, I'll just scroll down and here I'm just going to say spring.application.name and I can say job-service. Okay, like so. And now once the application name is set, okay, you can even move this to the top somewhere over here. Okay, and let me rerun this particular service. So I'll go to services tab and I'll rerun the job application. Now let us see what the logs look like. So ideally in place of unknown, you will have job service everywhere. Okay, because that's the application name now. So yeah, you can see quite a few logs appear. So you can see this is the Netflix discovery client, initializing Eureka, resolving Eureka endpoints. Okay, there are some more logs. And if you scroll down, okay, there are some checks that are happening and here getting all the instance registry info from the Eureka server. Okay, so it's fetching the registry and here like com.netflix.discovery client, the response status is 200. Fair enough. So if you scroll down here, so registering application job service with Eureka with status up. So our application has been registered as per the logs with Eureka server with this particular name, job service. Okay, and there are some more logs that appear. Okay, and then the server starts. So if you head over now here and if you restart, you will see this particular application up. Okay, and this is the URL of this particular application and it's called job service. So we have successfully registered our first service with Eureka. So the registration is successful. Okay, you are getting this alert, which is fine. Okay, so this is a warning that is coming up because Eureka is not able to ping some of the instances, service instances, which is fine. So we can ignore this. But the main part is we have successfully registered the job service. So that's about how you can register a microservice to Eureka Server. Welcome back. So now it's time to register the company microservice with the Eureka Server. And company microservice will be registered as a client. So we have already followed this process for job microservice. And what I would request you all is to take this up as a challenge. So try to do this yourself and try to register company microservice with the Eureka Server. So there are a series of steps that you need to follow, which we have already taken a look at. So try going hands-on on this, and what I would request is you can pause the video right now and come back and watch the solution. So welcome back. I hope you all had a chance to pause the video and attempt this yourself. If you were able to, congratulations. If you were not able to, that's perfectly fine. The goal of this is to get you hands-on with coding. Okay. So if you're not able to, that's perfectly fine. So in order to get this done, or in order to get or register company microservice, we need to first start with dependencies. Okay. So I'll head over to Spring Initializer. We'll copy the Spring Cloud version. Okay. And I'll just paste this below the Java version. So the Java version is mentioned here. I'll add this here. And then let us add the dependency for this entire tag, the dependency management for Spring Cloud. Okay, so I'll go over here and just below dependencies, I'll add this. Okay. And then I'll add the dependency for the Netflix Eureka client. So this is something that we will need so that it registers successfully. Okay. So here I'll add this dependency. Now, once you are done making changes to pom.xml, refresh or reload. So once you reload the Maven changes, dependencies are brought in. And what you can do is I'll just go to jobs application.properties and I'll copy all these properties. Okay. And then in the company microservice, I'll go to main resource application.properties, and here I'll paste the same properties. Okay. But here we also need to add name. Okay. So what I'm going to do is I'll pick up this name over here and I'll paste it over here. And here, instead of job service, I'll change this to company service, like so. I'll hit save. Okay. And now it's time to run our application. Okay. So this should work perfectly fine. Now, one thing I want to make a note over here is we have just added the dependency here. Okay. And we are just adding some properties to application.properties. Okay. And the entire mechanism of registering this application with Eureka Server is taken care under the hood. Okay. Now, this is what auto configuration of Spring Boot in action. Okay. So here we are not doing much. We are just telling Spring Boot that, hey, I need this dependency to be added. Okay. And why would you add this dependency? So you would add this dependency if you want your application to be registered with the Eureka Server, right? Now, if you're adding this dependency, so Spring Boot knows that, okay, so it needs to register this with the Eureka Server. And that is when it starts looking for these properties that, hey, where is Eureka Server? You need to tell me, and what all I need to do, and what is the name of the application. So if the application name is not there, it will register it as unknown. Okay. So if I comment this, so let me comment this and let me try to run the application without configuring the properties. Okay. So I'll go over here and let me rerun the company microservice. So let us see what happens. So the application is up and running. Okay. And if you scroll up over here, let me scroll up. So here you will see this message, registering the application with company service, registering the application company service with Eureka with status up. Okay. This is something weird right now. So if you go over here and if you refresh this Eureka page, you will see company service appear over here. And if you come to our source code, we have actually commented these properties. So what is happening actually over here? So if you comment this out and if you run the application, it will still register. And this is because of the auto configuration. So what happens is, by default, the values for these are provided. So this is the default value that is provided even if you don't add this. This register with Eureka property is also set to true by default, and fetch registry is also set to true by default. Now, if it's set to true and if it's auto configured by default, why would you explicitly specify this? So you should explicitly specify this because it's a good practice. And in future, if you make use of Spring Boot profiles, so there is this concept wherein you can have different application.properties file for different environments. So in that case, it's best to have these definitions across different properties files for different environments so that you know which environment is pointing where. So you might have different environments like dev, prod, and so on. Even QA, you might have a QA environment. So that's the best practice that you should follow from day one. Okay. And this was like Spring Boot auto configuration in picture or in action, I should say. Now, if I save this and if I run this again, I'll absolutely get the same output. Okay. So let me rerun. Okay. So it's rerunning. So essentially it's really good. So I'm teaching you the concepts, but it's really good that you experiment with things. Okay. What happens if I comment out a certain thing? What happens if I modify a particular thing? This is really, really important when you are learning programming because it helps you understand what's exactly happening under the hood. Because right now there are frameworks and everything makes your life so much easier. But what's happening under the hood, that is something that you need to understand. And how will you understand? By experimenting and tweaking the code. So yeah, the service is up. Now, if you go over here and if you refresh, you will see company service appear over here. So yeah, we have successfully registered 2 microservices with Eureka. Hey there, welcome to this class. So far, we have 2 of our microservices registered with the Eureka server. Now let us understand how we can make use of service names to communicate with our microservices. So the entire goal of introducing Eureka server was to make use of service names. Okay. So here in the browser, if I try to access the jobs API, so here I have localhost :8082/jobs. This is going to work with no problems. But what happens if I change this to job service? So if I say job-service. So let us see what happens. So this is not going to work. Okay. And even if you copy this, so if I copy job service here, and you can see it did not work. Now, if I copy the job service and if I head over to, let us say, Postman here, and if I paste it over here, okay. So let me remove this extra part. And if I send this, this is also not going to work. Okay. Now, why doesn't it work? Because accessing the service via its service name directly via browser or Postman is not typically possible because Eureka does not act as a router. Okay. So Eureka is a service registry and it is used or intended to be used by other microservices within the system and not by the external clients like web browser or Postman. So if you want to access your microservices via the service names in the browser or Postman, you will need to set up something like a gateway or something like that. So gateway will handle all the requests and it will do all the routing. Okay. So this is not going to work if you try to access it. So I'm just going to press Control Z here. Okay. And I'm just going to revert this to localhost and get this working. Okay. So this is about communicating with microservices externally. All right. Using the service name, of course. Now let us see how the communication would work within microservices. So let's say if we communicate to company service from job microservice, okay, how is that going to work with the help of service name? So let us say if I switch over here and here, if I say here in job service implementation, if you go to job microservice, in job service implementation, we are already communicating with the company microservice here. using localhost. So let us say if I change this to company-service, like so. So I'm using service name now. Now let me rerun the server. So what happens with this? So I'll tell you what will happen. This is not going to work. And let us test this. Okay. So we have the service register properly. And now if you head over here and if you try to get the jobs, you get no result, 200 OK. Now this worked because if there are no jobs, we are not communicating with the company microservice. So this worked. Now if I add a job, we have a job with company ID 1. Now if I say get jobs, this is going to break. Okay. And this is not going to work. So there is a reason why this does not work. So the reason is because we are using an instance of REST template over here. Okay. So if you switch over to the code, you're going to see all the errors here. Okay. And if you scroll up at the top, you're going to see unknown host exception. Okay. And there is a reason for this. So the reason is we are making use of REST template to make the call. Now REST template instance here is not load balanced. So we need to get a load balanced instance of REST template to be able to make a call to this particular service with the help of service name. Okay. So how do we do that now? So in order to do that, we need to create a new class over here. So I'll create a new class in job package. I'm going to call this class as app config. Okay, like so here. And here I'm going to have a definition. So I'll say public. I'll have a method here, REST template, like so. So this is going to return an instance of REST template. I'm going to say REST template. And this is simply going to return new REST template. Okay. Now, what is the benefit of doing this? This is going to be load balanced. So we are going to add this load balanced annotation over here, as you can see. Okay. Load balanced. And I'm going to tell that this is a bean. Now, what does this mean? So specifying bean tells Spring Framework that it needs to manage this object, or it needs to manage the objects of this class. And here I'm going to specify configuration. So what happens is load balanced annotation configures the REST template to use load balancer client under the hood. And this is a client that is capable of using service IDs registered with Eureka to locate the services. Okay. So in that situation, load balanced annotation is needed, and it's critical when you're working with Spring Cloud and Eureka for service discovery. Okay. So we are making use of this, and this annotation allows Spring Cloud to create a proxy for the REST template that is intelligent enough to understand the service IDs from Eureka and to load balance the requests across instances of different services. Okay. Or across instances of a particular service. So you get better capabilities or a REST template that is much more intelligent in that case. Okay. So here, now what I'm going to do at the top, I'm going to say we create an instance of REST template. I'm going to first say auto wired. Okay. And I'm going to say REST template here and REST template, like so. So we created an instance of REST template and we are saying auto wired. So this auto wire, what this auto wired means is we are telling Spring Framework to provide us the instance of REST template on runtime. And this is possible because we have mentioned or specified this as a bean. So bean means Spring is going to take care of managing that. Okay. So I'll scroll down here. We don't need this REST template. So I'll just comment this out. And now we are set. So we are using the intelligent version of REST template to call our microservice. So let me rerun this. So we'll rerun this and we will see the output as to how it works. Server is up, and if you head over to service registry, you should see the registration is successful because you're seeing the name here. Okay. Now let me try getting all the jobs. Of course, it will be empty. So we need to add a job and we need to send the request. So this time it will work perfectly fine, as you can see. So you're getting the results, which means the communication or the inter-service communication between different microservices is working with the help of service IDs or service names, whatever you want to call it. So yeah, these are some important concepts that you need to remember and understand about Eureka Server and inter-service communication. Okay, and it's important that you experiment a lot with the code, and that is what we did. All right. So I hope you have a clarity now as to how this works. Now, one thing I wanted to show you is here we have registered, job service, and company service. Okay. So if you want to deregister, you have to just stop the service and this name is going to go away from here. Okay. So if you want to unregister or deregister a particular service with Eureka Server, you have to just stop the service and it will deregister itself. So that's about the communication and load balanced REST template. Thank you. Hey there, welcome to this class. So far, we have 2 microservices registered with our Eureka Server. So now I would want you to take up a challenge wherein you would register the ratings microservice with the Eureka Server as well. So we are aware of the steps that we need to take, and this will be a good practice for you. So I would request you all to pause the video right now and get this rolling. So welcome back. I hope you all had a chance to do the solution. So let us get started with the solution ourselves. So the first thing we need to do here is we need to add all the dependencies like we have done for the other 2 microservices. So I'll get the cloud version tag over here and I'll set it in reviews microservice. So I'll close everything else. I'll open reviews microservice, pom.xml, and I'll even open up application.properties and I'll close this. So here I'm just going to scroll to the top and just after Java version, I'll add the Spring Cloud version. Now we need to add the dependency over here. So the dependency is Spring Cloud Starter Netflix Eureka Client. Okay. So I'll add this over here. So I can add somewhere over here. And also we need to add this dependency management tag for Spring Cloud. Okay. So I'll go over here and just after dependencies, I'll paste. So we have made few changes to pom.xml and I'll hit refresh. So this refresh should work perfectly fine. Now we need to head over to application.properties. And what I can do is I can open up the application properties of any other microservice that we have configured to work with Eureka, and I can like get some tags from there. Okay. So I've opened the job microservice here. Okay. So what we need is we need to copy this entire thing over here like so. So we are aware that this is like to make this particular service aware of the Eureka Server endpoint. We are telling register with Eureka true and fetch registry as true. We need to specify the service name. So we'll add the service name. Otherwise, our application will be registered as unknown. Okay, so the service name can be review service. So the name is added. Okay. Now what we can do is let me restart this particular service. Okay. So let us see the output and let us see whether it successfully registers or we get any issues. We should not get any issues. So if you scroll down here, okay, so you should see this message over here. If you scroll down, registering application review service with Eureka with status up. Now, if we head over to the Eureka page and if you refresh, you should see review service with its endpoint appear over here. So the service has been successfully registered. So this is how you can get review service registered with Eureka Server. Hey there, welcome back. So what are we going to do in this lecture is we are going to update the get request to get a single job. So as of now, if you add a job over here, and if you try to get a job, we are getting the job object. But what we need to do is, instead of company ID, we can even get the company object. So along with company ID, we'll have the company object as well. So this is something that we need to do, and we will be making use of service discovery and inter-service communication. These are the two mechanisms that we are going to do hands-on, and we are going to implement this. Okay. So without further ado, let's get started. So I'll switch over to IntelliJ and I'll close everything. So I'll close all the tabs. I'll switch over to jobs microservice, and within jobs, I'll straight away go to the file which I need is controller and the implementation. Okay. So here in controller, if you scroll down, you have this get mapping. Now this is a get mapping that is responsible for getting the jobs by ID. So what we are going to do is we are going to go to this service method here, which is being used, get job by ID. And this is the method that we are going to modify over here. Okay. So what is the modification we need to do? So we need to add company object to the response. So instead of job, we need to have job and company. And we already have a DTO class for this. So this is job with company DTO. So this is what we are going to return. So to get all the jobs, we were returning a list object of this class, but we don't need to return the list. Instead, we are going to only return this object. Okay. And the reason is because we are only fetching one job. So I'll add this over here. Okay. And now what I need to do is here I'm getting the job. Okay. So I need to remove return from here. Okay. And I need to accept job into a job object like so. All right. And now we need to transform this job into a job with company DTO object. Now, how do we do that? So we have already done this and we have created a method for this. So this is the method which is which returns job with company DTO, and it converts a job to this particular object, and it manages everything, like it does the query to the company service and all. So having this method makes life much more easier, as you can see. Okay, I can call it from multiple service methods and multiple mappings here. So I can simply say return, and I can say convert to DTO, and I can simply pass the job object. That is it. So our job is done here. Now we are getting these red marks, and this is because in the service class, if you go here, we are returning the job object. So we need to say job with company DTO. And if you come back, the red marks go away. Now there is one more place where we will be getting the red marks, and that is in the controller. Okay. So the reason we are getting this in the controller is because we were accepting the job object here, but now we have changed this. So we can simply change here. We can say job with company DTO, and here also we need to say job with company DTO. Okay. So this will be job with company DTO object. It's important that you rename the objects as well. And the reason for this is it's simple, so that you know, okay, what is this object holding? So if you call this object as job, and if someone else is looking at your code, you will think, or that person will think that this object is holding job, but actually it's not. It's a instance of job with company DTO. Okay. So I'll say job with company DTO here as well. And I believe we have solved it. We have all the red marks gone. So what happens is whenever we get a GET request, we head over to the service class and we call this method. Within this method, we are getting the job, the instance of job with the help of this ID, which we got from the controller. And we are converting this job into DTO. And how are we doing this? We are doing this with the help of this method, which we already wrote earlier. And this is a method which takes the job object. It sets it creates the object of job with company DTO class. It sets the job inside, it fetches the company, and for that it retrieves the company ID here, and then it sets the company over here, and then it simply returns the object. So we are simply making use of this method here, which is enabling us to convert our jobs to DTO, and we are simply returning the output of this method here. Okay, so this is the entire mechanism. Let us rerun our service. So I'll rerun the job microservice. Let me rerun and let us see if we are getting any errors. So ideally we won't get any errors because I believe we have done everything correctly. But still, when it comes to programming, you never know. So yeah, the application is running, and here we can try getting jobs. We'll create a job added successfully. You have one job added. Now let us try to get a job with ID 1. So earlier we were getting only the job object. Now you will get job and the company object as well. So we are getting the response and this thing is working perfectly fine. So now we have an API with job and company details. And I hope you all have a clarity as to how the communication works in microservices architecture with the help of Eureka Server. Welcome back. So here now I'm on Postman and I have this query executed. This helps me get a single job from my jobs microservice, and as a result I'm getting the job object as well as the company object. Now the thing is, I don't like this response structure. Okay, so I want to restructure this a bit. I don't want this job keyword over here. I don't want this in the form of nested JSON over here. So this is a JSON within an external JSON. Okay, so how do I change this? So to make these changes, you can head over to the DTO class. So here I'll open the DTO. Now here, since we have added the objects of both the classes, they are being converted into JSON over here. Instead, what I can do is I can go to the job class. So from the job class, I can copy all the properties. I can exclude company ID here and I can just add them over here. Okay. Now let me remove these getters and setters and let me add the getters and setters. Okay, so I'll add the getters and setters for the newly added fields like so. So you can see this class has been modified now. Okay, we don't need to, or we will need to make any changes here. So let me see. Okay, so we are setting the job. So here we won't be able to set the job. So this error says that this setter does not exist, and it's absolutely correct. It does not exist. So what do we need to do? So with the help of this particular thing, we were able to set the job. Now what we can do is, to solve this, we can have a mapper created. Now what is the role of mapper over here and why do we need it? So we need a mechanism to map job and companies with the job with company DTO. Okay, so this is a DTO that we have created and we need a way to map the company objects and the job objects to this particular DTO. And that is what the role of a mapper is. So what I'm going to do is, let me head over to the project. I'm going to say new Java class and I'm going to say mapper dot job mapper. So what I'm doing is I'm creating a new package called mapper, and within this package I'm creating job mapper class and I'll hit enter. So you will see job mapper appear over here, and here I'm going to have a definition of a method which is going to do the mapping for us. So I'm going to say public static. So after static we will have the return type. So I'll say job with company DTO here, and I'll say map to job with company DTO like so. Okay, Now here I'm going to have the parameters. So I'm going to say job, and this is going to be the job object. And then we are going to have company, which is company object, like so. And I'm going to have open and close square braces. Okay. Now let me close this and let me reformat the code. Okay, so now what we can do over here is we need to create an object here. Okay, so I'll say job with company TTO, and I can say job with company TTO here is equal to new job with company TTO, like so. And here I'm going to start mapping everything. Okay, so I'll say job with company TTO dot set ID. So we need to set the ID. Then we need to set the title. So this is job title. We need to set the description. So we need to set one by one all the parameters here. Okay, location, max salary, and we also need to set the min salary. And let me see if anything is missing. So I'll say set max min ID. We don't need, so we need to set the company. So company is missing. Okay, so these are the parameters that we need to set. So I'll say job dot get ID. Okay, so this is done. I'll say job dot get title. This is also done. Job dot get description. I'll have job dot get location. Job dot set max salary, and job dot get min salary. And I can even have job dot get company or set company, sorry. Okay, so we don't have job dot, but instead I'm just going to pass in the company object. Okay, so this is a company object that we are accepting. Okay, and now I'm just going to return this object. So I'm going to say job with company TTO, like so. And we are done. So this mapper is created. Now what we need to do is we need to use this mapper over here. So I'm going to delete this line here. Okay, and here what I'm going to do is I'm even going to remove this line. So let us remove that line too. Now here, after we get the company object, I'm going to say job with company DTO. I'm going to create the object is equal to job mapper dot map company with DTO. And I'm going to say, job comma company, like so. Okay, and I'll end this with a semicolon. Okay, so this should be fine now. Let me move this to the next line. Okay, so this is much more readable now. And what I've done is I've removed everything. So I've made this code a bit light. So we are fetching the company object using the job object, and we are passing the job and company to a new mapper that we have defined. And this is a mapper that exists here. Okay, and with the help of this mapper, we are mapping the job and company objects to that of DTO. Okay, so this way you can now imagine, like, you can modify this to any structure because you have a mapper now and it does the job of mapping. If you do any changes over here in the structure, you have to just change the mapping here. That is it. And it will take care of everything. Okay, now what I can do is I can simply rerun this application. So let me redeploy job, and this should result in the structure changes in the response. Okay, and that is what we wanted. So application is up and running. Okay, registration status 204. And if you go over here in Postman, this was the response that we were getting earlier. Okay, now if I send the request again, we won't get any output. Okay, we got an error. So let us take a look at the error that we got. Let us understand. Job is null. Okay, so we need to handle the null case as well. Okay, so we need to handle null, which we have not handled, but the mechanism is working. So if I create a job and if I try to get a job here, you can see the structure has changed now. Okay, so you can see the structure is working perfectly fine and there are no issues as such. So we have modified this to a better output or a better endpoint. And this is applicable also for this because the DTO is same. If you try to get all the jobs, you will see this is also updated now. And this is because the DTO is same behind the scenes. So this is about how you can restructure the response to match your requirements. And this you can do with the help of DTO. So it's getting fun and exciting. I hope you all enjoying. So that's about this class, and I shall see you all soon. Thank you. Hey there, welcome back. So right now we have our microservices up and running. Now the thing is, if you go to the jobs API and if you fetch the jobs, okay, we don't have any jobs. So let me add a job. Okay, so there's this one job added. Let me add a company also. So there is one company that exists. So I'll try fetching the job. So here, if you fetch the job, you're getting the job details as well as the company details now. But what I want to do is I want to even add the review details. Okay, so we don't have that added yet. So let us work towards adding and bringing in review as the part of the jobs API. So I'll switch over to IntelliJ. Now what we need to do is there is a series of steps that we need to do. So for company, we went to jobs microservices, and here in external, we created the company class. And this is a class that represented the company object. And then we mapped or we added company into the DTO object here. So DTO class. And then with the help of mapper, we created a mapping. Okay. And then there was some functionality that was written in the service class over here, which helped us fetch the company and do the mapping. So this was the process that we followed for company. We need to follow a similar process for review. So what I'll do is I'll go to the review microservice and let us see what all elements we are storing for any given review. So we have these things that we are storing here for the review. So I'm going to copy this. Now let us head over to external package in the job microservice. And here in the external package, I'm going to say new, and I'm going to say new class. And I'm going to call this class as review. Okay. So this class is created. Now what we can do is we can paste in the properties that we copied from there. Now here, I don't need to store or show the company ID. So we can get rid of this. So we can just have ID, title, description, and rating over here. All right. Now what we need to do is we need to have getters and setters for this. So I'll generate some getters and setters. There you see. So the review class is now set. Now, as a next step, what we need to do is we need to add review to job with company DTO. So here in job with company DTO, I'm going to add review here. So here I'm going to say private review like so, and I'm going to have a review here. Now what I can do is I can generate getters and setters for this. Okay, so I'll go to the end like so. And here I'll generate getters and setters. I'll select review. So we have this set now. Okay. Now what we should also do is we should rename this DTO. So this says job with company DTO, but actually now we have enhanced this DTO to also include review information. So we can just call it job DTO because this shows the job information along with the company that has posted the job and the review of the company. So I'll just right click on the class here and I'll go to refactor and I'll say rename. So here I'll just say job DTO and I'll delete this. So this is a new name. I'll click on refactor. I'll keep all the settings as default. So you will see some checkboxes over here and I'll say refactor. Now what it will do is it will refactor everything. Well, all right. So wherever we are using this class, it will refactor, and it is also asking us a couple of details here. So if I'm able to expand this, you can see So it is telling us IntelliJ, we have created a few local variables for this particular class, and we are calling that local variable as job with company DTO. And this is most likely in the service implementation. Okay, so here, this is how we have implemented it. So since we are changing the name of the class, do we also want to rename the variable name to job DTO? And yes, of course, we want to do that. All right, so I'll say select all and I'll say OK. So the refactoring is done. So if you go to job service implementation class and if you scroll a bit, you will see the class name has been changed everywhere, and also the local variable object name. So this is the local object that we had created. So this is also renamed to reflect or match the new class. And this is also true in the controller. So if you go to controller, you will see job DTO here, which is really good. And this is also the local object that we have created, and this is also renamed. So IntelliJ makes our life easy this way. Okay, so imagine like without IntelliJ, if you're coding here and you rename the class, you will have red marks everywhere and you have to go and see, hey, we're all like, this is not working now. So I need to change, even I'll have to change the imports. So imports are also automatically managed by IntelliJ itself. So everything is renamed automatically whenever you change an object. And that's the magic. So here, if you were not using IntelliJ, you would have to come and manually change this. Okay. So now this is done. We have renamed this. Now what we need to do is we need to head over to the mapper. So here in the mapper, we need to do the mapping. But before mapping, I'd say here in the service implementation, we need to get the review as well. Okay. So here, since we are getting the company, we need to, so every company has a company ID, and with the help of that company ID, you can get the review. So now here, we need to call the review API. So if we take a look at the review API, so let us go over here. So whenever you fetch a review from the company, you get a list. So there can be multiple reviews against a particular company. Okay. And how we have handled this is, here we are getting a single object. Okay, so we won't be using get for object, we will be using exchange. So I'll say rest template dot, so I'll say exchange here. Okay, and here I'll pass in the URL. So I'll copy the URL from here like so. So this is a URL. Now instead of localhost, I need to use the service name. So the service name is review service. So I'll say review service like so. And here, this needs to be dynamic. So what we are going to do is I'm going to remove this like so. And I'm going to copy this here. And here I'm going to say space and let me say job.getCompanyID. So here I'm passing in the company ID. Okay, now exchange method requires some parameters. So this is the URL that we have passed in, and we need to specify the method as well. So I'll say HTTP get. I'll specify null as the third parameter, and I'll specify this over here. So I'll say new parameterized reference type, and I'll say list here. Okay, and this list is of the type review. So this is what we are getting as the response. Okay, and I'll keep this to empty and I'll put a semicolon. Okay, now here what I'm going to do is I need to accept the response. So I'm going to say response entity like so, and here I'm going to say review response like so, and response entity has list and it's a list of review type. So what have we done over here now? Okay, so we have not made use of get for object because we will need exchange method from REST template, and this is used to get the list of review objects. Now exchange method is much more versatile than get for object, and it's useful when the response type is a generic collection. So here you have a generic collection type, and this is where exchange is useful. Okay. Now get for object is particularly useful whenever you know that the response that you're going to get is going to be a single object. But when you get list as the return type from the API, it's better to use exchange. Now, what we have done is we have passed in a few parameters. Okay, so the first parameter is the URL here. So you can see the URL that I have specified. I have specified the service name, colon, this is the port, and then I have, like I'm calling the reviews API, and I'm passing in the company ID here. Okay, now, so this is the dynamic URL that is crafted. Then I'm specifying the method type over here. So this can be get, post, put, or anything. Okay, but since it's a get request, I'm specifying get over here. We have null mentioned over here. So this specifies the request entity that we need to send to the server. And in this case, there is no request body. So since the request body is null, we have specified null over here. Then we have the parameterized type reference over here. This captures the generic type information of the expected response. So we are telling that the response is supposed to be in this format. Okay, this is how it is working, and then we are accepting the response over here. Now what we need to do is we need to get the review response. So I'm going to say list, and I'm going to say review, and here I'm going to say reviews is equal to review response dot get body. Okay, so from the response we need to get body that we need to convert to this reviews, which is of list type. Okay, so this is done. We have the list of reviews that we are fetching from the API call, and we are doing this API call to the review microservice. Now what we need to do is with company, we are mapping job and company, right? So now what we need to do over here is we need to pass in reviews as well over here, like so. So this will be passed to this particular method. Okay, so this step is not needed actually. So I'll just comment this out. Okay, so we are already doing the mapping within this particular method. So I commented this out, and we are passing reviews also now. So I'll go to this method here now, and I'll add reviews over here. So I'll say list, and it is of reviews type. Okay, and I'll say reviews like so. Now what are we doing with the reviews? So we'll scroll down, and here I'll say job TTO dot set review. Okay, and I'll pass in reviews. Okay, so we are getting an error here because we are passing in the list. So if you go to job DTO, here we have specified that a single job will have only one review, but actually that is incorrect. So we will have the list of reviews. So I'll just make that modification here. Okay, and I'll call this reviews. And with this change, the getters and setters will also get updated. So I'll say generate getter and setter, and I'll regenerate this. So how this works is one job is associated with one company, and then that company can have a list of reviews. Like, of course, many users will post in the individual reviews. So there will be a list of reviews, right? Now here, what we need to say is we need to say set reviews, and we are done. Okay. So this is updated now. What we will do is we'll head over to services, and we'll restart the job microservice. And the reason for this is because we have only made changes to the job microservice and not to any other microservice. So we'll wait till the application is up and running. So it seems that it's up, and we'll head over to Postman here. So we won't have any jobs because we have restarted. So I'll just add a job, and I'll try to fetch the jobs. So now if I try to fetch the job, you see reviews are empty. So we need to add some reviews against company ID 1. So I'll say company ID 1, review number 1, description is also 1, and I'll add this. Now let me add one more. I'll say 2, and I'll say 2. Now let us call the jobs API. So now if you call, you will see the reviews also getting populated. Okay. So what we have done is we have added reviews into the jobs microservice, and reviews are also now being a part of the response that we are getting with the jobs API. So this is how you can work with different microservices. Now to outside world, whoever is calling the jobs API, he's not aware of the inner details. Okay, he does not know like how many microservices are being called in the background. Okay, you can even mask this URL. So you can have something like a gateway or something that you can set up. Okay, and that thing will route the request to the respective APIs. So all that can be done. But the main point over here is to show you how you can communicate effectively. And we are also making use of service registry, which is Eureka Server. So keep that in mind. All right. So that's about this class, and I shall see you all soon. Thank you. Hey there. Welcome to this class. So let us start talking about behind the scenes of Eureka Server registration process. So we have a couple of microservices, and then we have a service registry, which is Eureka Server in our case. So a microservice will register itself. The other microservice will send a service discovery request, and it will do that to communicate with that particular microservice. So this is how the entire process works. Now, for this to work, every microservice in the microservice architecture needs to register itself with the Eureka Server. Now the question is, how does Eureka Server keeps track of all the microservices, and how does it manage everything? So the number one thing is registration. So each microservice instance will register itself with the Eureka Server, and the registration does happen with the help of heartbeat signal. And this signal is being sent to Eureka Server at regular intervals. So how does it work? So it works with the help of heartbeat signal. And during the registration process, the microservices provide information such as the host name, IP address, port, metadata, health status, and so on. So all this information about themselves is being sent to the Eureka Server for registration. Now, after initial registration, so this is not the end. So this was just the registration process. Now, after initial registration, the microservice is responsible for periodically sending the heartbeat signal to the Eureka Server. And this signal is an indication that microservice is still active and functioning properly. Okay, so because of this signal, the Eureka Server also knows that, hey, this microservice is up and running, and it uses this to keep track of the services that are up. Now, when are these heartbeat signals sent? Now, the intervals between the heartbeat signals is configurable and can be adjusted based on the requirements. So whatever requirements you have, you can even specify a custom duration. All right. Now, Eureka Server does heartbeat monitoring. So Eureka Server will monitor the heartbeat signals from each registered microservice instance. And if Eureka Server stops receiving heartbeat signals for a particular microservice for a specific amount of time, it will mark the instance as down or out of service. And Eureka Server will maintain the list of all the available and healthy microservice instances based on the received heartbeat signals. So this is about Eureka Server and how it makes use of this concept, heartbeat signal and heartbeat monitoring, to keep track of all the microservices in the network. Now, heartbeat mechanism ensures that Eureka Server has an up-to-date view of registered microservices and the health status. Okay, so now let us do an experiment. So I have a few microservices up and running here, as you can see on IntelliJ, and they all are registered with service registry. So if I go here and if I go to Eureka, so this is the Eureka's page, and if I scroll down, you will see like there are 3 microservices that have been registered, and Eureka Server is also up and running. So this is working perfectly fine. Now what I can do is I can simply shut the Eureka Server. So Eureka Server is up and running. I'll simply shut the Eureka Server. And now if you go to any of the microservices, you will start seeing some stack trace. So let us wait for a while, and essentially you will see the heartbeat mechanism in action because this is not working. Okay, so if I refresh this, the server is down. Okay, and here now if you go, let's say we go to review, so we see some stack trace now. Okay, so you can see, so this stack trace has started coming in. Okay, so you can see over here com.netflix.discovery transport exception cannot execute any request on any known server. Okay, and if you scroll down, it is saying it was not able to send the heartbeat. Okay, so it is sending the heartbeat to the Eureka server and it is not able to. So you see one more stack trace and it tried to send again. Okay, and you'll see this again and again. Okay, so as long as it tries, it is going to print all this as a stack trace. And you can go in the job also. So here also you will see the same thing. Okay, so if I say Control F and if I search for heartbeat, and let us say if I search in company microservice. Okay, so okay, I need to search on this side. So I'll say heartbeat. You can see a lot of things that have been highlighted with this keyword heartbeat was unable to send the heartbeat. And this is for all the applications. Okay, so you will see this coming in for all the application. So if I search for job also, so here if I search for job, so let me say heartbeat, and you can see send heartbeat is the function or the method that is being used, and it's throwing an exception here. Okay, and you will see this message here was unable to send the heartbeat. So this is from job service. So this is the proof that this is how it works. And now if I turn this on, okay, so let's say I turn on the review, and if I scroll down in job microservice, there is literally an exception in the end. So service was up and running. Now if I refresh, we don't have any instances up and running, and now slowly everything will come in. So you can see company was registered. So if you scroll down here, you can see it got registered. Registration status 204, which means that it got registered. For job, it's not yet registered. Reviews, let us scroll down and see what's up with reviews. It's registered. So jobs is pending. Okay, it got registered too. So now if you go over here, okay, you can see all the three microservices have been able to register themselves. So this is how this heartbeat mechanism works. And with the help of this, Eureka Server is able to keep track of all the microservices that are there in the network. And this is really helpful. And this entire mechanism is known as heartbeat mechanism. All right. So that's about behind the scenes as to how Eureka Server works.